Welcome to Brain Vision.
So essentially, we just need to find the magnitude of all of these tension forces. So we can say tension sub A would simply be equal to the mass times mass sub 1 times gravity. This would be equal to 0.0360 kilograms. This is simply due to the sum of forces in the y direction equaling 0. And then this will be times 9.8 meters per second squared, the acceleration due to gravity. And we find that tension A is going to be 0.353 newtons. Now the tension in B would be equal to both the masses, so m1 plus m2 times gravity. So again, just the weight. However, now there's two masses. So this would be tension sub B would be equal to 0.0360 plus 0.0240. This is kilograms, and times again 9.8 meters per second squared. We find that the tension force of tension sub B would be equal to 0.588 newtons. So this would be your B, this is your A, and then for C, we can say that the sum of forces in the x direction equals 0, because this is in translational equilibrium. And this would be equal to TC minus T sub B cosine of 36.9 degrees. And so we find that TC is going to be equal to 0.588 newtons times cosine of 36.9 degrees. And we find that T sub C is going to be equal to 0.470 newtons. Similarly, we know that T sub D is going to be equal to 0.588 newtons. However, this will be now cosine of 53.1 degrees. So this is going to be equal to 0.470 newtons once again. Rather, my apologies, 0.353 newtons. My apologies. And so to find the tension sub E, sub F, and just sub E and sub F, the last two, we find that the sum of torques is going to be equal to 0, because this is in a rotational equilibrium as well, and this would be T sub E times 1 meter minus T sub D times 0.8 meters, sine of 36.9 degrees, and then minus T sub C of, again, sine of 53.1 degrees, and then times 0.2 meters, minus mgl over 2, so essentially the weight. And so we find that T sub E is going to be equal to 0.353 times 0.8 sine of 36.9 degrees plus 0.470 times 0.2 times sine of 53.1 degrees, and then plus 0.12, 9.8 times 0.5. And this would equal 0.833 newtons. So this would be your answer for E. This would be your answer for C. Rather, this would be your answer for D, and this would be your answer for C. My apologies. And for part T sub F, this would be, in order to find T sub F, we have to say that the mass total is going to be equal to the mass plus m sub 1 plus m sub 2. And this is equaling 0.12 plus 0.036 plus 0.024. Add those up, we're getting 0.180 kilograms. So we know that the weight total, it has to be equal to the mass total times g, and this will be equal to 0.180 times 9.8 This is giving us 1.764 newtons. So to find T sub F, we know that T sub E plus T sub F equals the weight total. So T sub F would be equal to the weight total, 1.764 minus 0.833. And we find that T sub F is going to be equal to 0.931 newtons. So this would be your answer for T sub F. That is the end of the solution. Thank you for watching.